Assalamu alaikum. Hi folks, welcome back again to the second part of this tutorial. In the first part we talked about three main groups or types of students test. The first one is the students one sample t-test, the second is the unpaired t-test, and the third is paired t-test. So after calculating the p-value of each of these tests, it's recommended to evaluating the effect size using Cohen's d. So Cohen's d statistic tells us how large the difference is between the groups, while the p-value, the results of p-value of each test describe or explain whether if there is a different significant difference between groups, or this difference is could to be due to the chance or no. So the Cohen's d statistic tells or allows to understand the magnitude or the meaningful of the difference between groups. So for example, the first one test, the statistical test refers to one sample t-test. To the p-value indicate that there is no significant difference. We can, for example, apply or write the Cohen's statistic like this: mice percent, more than percent, Cohen d, and also weight tilde 1, and for example standard value, and click to run. So in this case the effect size is 0.07, which refers to negligible effect. So in this case the difference is negligible between the mean of weight and the value of 20. We'll also apply this measured in the second one, which refers to Welch t-test, because the results or the equality of or the difference between results isn't equal. So because in this case, for example, var dot equal to false refers to that the variance between groups isn't equal. So there is a heterogeneity in this case. So in this case we have a Welch t-test. So we measured the effect size using this structure. Gender weight, yes, gender weight, percent more than percent, Cohen's d, we should put weight tilde group and comma var dot equal false. So in this case the effect size equal to minus 6.57, which is very large magnitude. The effect or the difference between groups, one female and male, is very large, dependent of the value of effect size. So, and the third is the paired t-test using this following also: minus 2%, more than percent, Cohen's d, weight tilde, also gender, comma paired equal to true. In this case also the effect size is when we have in this case for example, in this case we have effect size equal to 8.08. It refers to a positive value. When we have a positive value of effect size, that refers that the mean of group 1 is higher or more bigger than the group 2, the mean of the group 2. Inverse that case in this second t-test or unpaired t-test, which refers that effect size equal to a negative, a very large negative value, which is minus 6.57. So this is refers that the mean of the male is more higher than the female. Very well. So let's move on to the next point, which is refers or corresponds to how we can represent this results of this t-test, the one sample t-test and the Welch t-test and this one, I think this one, the third t-test. So the question is, what would it take to make this work? So we did in the earlier in the boxplot tutorial, we must load in the appropriate package, which is library ggplot2 and use the, for example, package or ggplot2. No, there's I forgot to put ggplot2. Yes, like this. So using the function ggplot, for example, like that ggplot, like what I did in the ggplot tutorial. Ggplot data, select the appropriate data, mice, comma, aesthetic graphical, open the parenthesis, and put the x, which is, for example, represent the in this case, for example, group nice to group, and y represent weight. I think weight, yes. No, gender. The independent variable is gender, and y is weight, yes. For example, color, gender, plus geom box plot, like this. So this figure shows the results of the distribution of gender and the weight of each group of gender. In this case, for example, what would it take to make for example, it work? We're using the results of t-test. So the results of P and significant difference and statistical test and the number of samples. We, for example, want to put it in this figure to make it clearly and representable, ready to publish. So first of all, we should, so this function, which refers to the command of, this one, command of the t-test, the per t-test, we should name this command like this, for example, test3 equal to. So only we, for example, can put test3 and click to run. Yes, to, for example, get this to this output. And we should, for example, write this comment. So I will copy this comment, all the comment, copy and put here. For example, here, I think here. Nice2 test3. Oh, no. There is. I should, for example, this put, for example, the test2 here and select test2, and here, which refers to the pair t-test, we must write, for example, test3 equal to, no, not here, t-test, yes, here, test3 equal to the comment corresponds to the test for comparing between gender weight, mean of gender, mean of the weight of each gender. So test 3 represent the results very well of the test or parametric test or paired test, also called dependent t-test, which refers that there is a difference significant between the female after and before for weight as dependent variable. So here we put, for example, this comment which refers to this figure, and add the following comment. Add the comment labs subtitle get summary states and put no, I think, oh sorry, my bad, I misunderstood. Get test, yes, test label, and here we must write the test, for example, test 3 detailed true. So as the figure shown, this is the results of, the distribution of gender before and after for the dependent variable weight. In this case, the gender is the independent variable and the weight is dependent variable. And this t-test with t represent this number, represent the number of samples minus 1. This is the results of t-test, and the p-value is less than 0.0.1, and the name this is the number of samples. So in this case, this results refers to the output of statistical test, which is the paired or the dependent t-test. So move on to the next one, which is the test 2. So test 2 represents the output of the independent t-test for comparing between male and female. So as the same, for example, structure, we can copy it and put it here. For example, should only, for example, place the appropriate data set, and this should be group. Here is false group, and here weight, say the same, and here group. Very well. Only this we must write test 2. Very well. So in this case also we have draw the distribution of each group, female and male, of the dependent variable or response variable weight, and all comment or all output of the independent t-test, or the independent, or also called the unpaired t-test. Finally, that's all of this tutorial. Feel free to, if you have any question or suggestions, feel free to leave them below in the comments. I will also include all our comments in the description or in the comments. So thank you for your watching.